my amazing Algebra 1 students. This is Mrs. A and I love math. We are back with lesson 6 in our orange book, and we're talking about rules for addition. So when we're talking about signed numbers, we've been doing these on the number line, and I tell you what, that's going to get really tedious as numbers get bigger and bigger. So what we need is some rules that are always going to be applicable. So let's do one more number line exercise here. And now we're going to use the number line to try to establish some rules. So I want you to look at this. We have two numbers, +1 and +3, that have the same sign. So we're trying to develop some rules for signed addition. So we have +1 and +3 that we are adding together. So we would start at 0, we would take one step, and then we would take 3 more steps, and we wind up at the number 4. Well, that's nice because 1 + 3 is 4, and we wind up at +4. Now we started out with two positive numbers and we ended up at +4. So now let's do the same thing, but now we've got a -1 and a -3 that we're adding together. So we would start at 0 and we would take a negative backward step, negative step, and then -3 steps, and we would wind up at -4. So remember, 4 was the sum of 1 and 3, so since we're adding the same sign, we're going to go to -4. So here is the rule that we're going to learn. When we're adding like signs, we add the absolute values. 1 + 3 is 4. 1 + 3 is 4. Remember, absolute value is what the number is without the sign on it. It's the distance of the number from 0. So 1 + 3 is 4. 1 + 3 is 4, but then we take the sign that is in common between the two numbers. So I have a real quick way to say it. Same sign, add, take the common sign. So when I say same sign, add, we're really adding the absolute values. We're adding the numbers without any regard to sign. Same sign, add, take the common sign. So when we have the same signs, we add the two digits together and we take the common sign. When we have the same sign, we add the two digits together, but then we take the common sign. Okay, so that's going to be our addition rule for same signs. So now we're going to do the addition rule for opposite signs. Okay, so now we're going to do these over here that have opposite signs. We have a -2 and a +5, a +2 and a -5. So let's do those on the number line and see what happens. So with the -2, we'll take 2 backward steps, and then we'll turn around and take 5 forward, and we wind up at a +3. Okay, +3. So then down here, we're going to take 2 positive steps, 1, 2. And then we're going to take 5 backward steps from there, and we wind up at a -3. Okay, so let's see if we can come up with a rule that's going to help us so that we don't have to do it on the number line all the time. So we had opposite signs to start out with. We're adding opposite signs, okay? And what we ended up with was 3, which is actually the difference of the two absolute values. And then we took the sign of the bigger one. The bigger number won the tug of war, didn't it? We went left 2 and then we went right 5, but because the 5 was bigger, we wound up on the positive side. So we did the same thing over here. We took 2 forward, but then we took 5 backwards. 5 outranked the 2, so we wound up on the negative side. So here's our rule for opposite signs. Opposite signs subtract, take the sign of the greater valued number. Okay, so when I say subtract, I mean subtract the absolute values, the values without the sign. So opposite signs subtract, take the sign of the greater. So opposite signs, we're going to subtract. 5 - 2 is 3. Take the sign of the greater valued number, which was positive, and we wind it with +3. Opposite sign, subtract. 5 minus 2 is 3, but the negative number was greater, so we take the negative sign and get the negative 3. So those are going to be our rules. Same sign, add, take the common sign. Opposite sign, subtract, take the sign of the greater. So now we have a definition. Additive inverses are the same thing as opposites. So -5 and +5 are additive inverses. -5 plus a +5 is 0. So when we add additive inverses together, we get 0. This sign, let's practice. Notice I've got +7, -3, -7, -3, -7, +3, +7, +3. I have all the different options. So let's talk about our rules again. So let's look at our same sign. We have a -3 and a -3. Same sign, add. 7 plus 3 is 10, but take the sign that is in common. So we have a common sign, we take that sign. So let's go down here. +7, +3. Same sign, add. So we get a 10. Take the common sign, which is positive. Now when we have a positive, we don't often write it there, okay? Opposite sign, subtract. So 7 take away 3 is 4, but take the sign of the greater valued number, which is going to be positive. Opposite sign, subtract. 7 minus 3 is 4, but we take the sign of the greater valued number, which is negative. And there you have it. Okay, so here we have same sign, add. So that's going to be a 10. Take the common sign, which is negative. Opposite sign, subtract. So 8 minus 2 is 6. Take the sign of the greater valued number, which is positive. Opposite sign, subtract. 8 minus 2 is 6. Take the sign of the greater valued number. Same signs, add. Take the common sign, which is positive. And that is pretty easy. Now let's talk about what happens when we add more than two items together, more than two numbers together. So if we start over here, we have -5 plus 4. And since they're opposite signs, we would end up with a -1, right? The difference is 1, but then we take the sign of the greater number. So we get a -1. And then we're going to add the -1 to the -3. So now they're the same sign. So -1 plus -3 would be add the two absolute values. So we get a -4 because we take the common sign. So now we have a -4, and we add that to the +2, and now we have opposite signs again. So we're going to subtract. 4 minus 2 is 2, but we take the sign of the greater for a -2 as the sum of all of those numbers. So now, what would happen if we change the order? Okay, so let's say we change the order, and they're the same numbers, but now we're going to add the positives together. So we have two same signs here, and we're going to have a +4 and a +2, so the same sign, add. We get a 6, and we take the common sign, so we get a +6. And then what if we added these two negatives together, same sign, add, and we get a -8. Then what if we took the +6 and the -8, we added those two opposite signs together? So we really subtract. 8 minus 6 is 2, but we take the sign of the greater, and guess what? It's -2 again. Even though we added it in a completely different order, it is still -2. So guess what? Order does not matter. As long as we follow our rules of addition, we do not have to follow the order. Very often when I'm adding a string of unlike terms, I might add all of my positives together and all of my negatives together, and then add those two together, and then I'm done. It's a little bit faster. So here we're going to add it left to right first. So -3 to +2, opposite sign subtract, and I get a -1. So then I add the -1 to the -2, which is the next one. -1 plus -2 is same sign, add. So I get 3, but I take the common sign, so I get a -3. And then I add the -3 to the +4, and I get opposite sign, so 4 minus 3 is 1, and I take the +1, so the answer is +1. So now let's do the same set, but let's switch it up a little bit. So look at this, I have a +2 and a -2. We just learned that additive inverses add to 0. So those two add to 0, so then all I have is a -3 and a +4, which are opposites. 4 minus 3 is 1, and it ends up being a +1. And that works no matter how you add it. It is important to remember that addition is commutative, which means it does not matter in which order we do it, but subtraction is not commutative. So we can only do it in whichever order we want when we are adding. So 3 minus 4 is a -1, and 4 minus 3 is a +1. We do not get the same thing when we switch the order with a negative problem. However, we can change subtraction to addition of the opposite, and when we do that, then we can use the commutative property. So instead of switching it around like this, I can use this principle. So 3 minus 4 is the same thing as 3 plus a -4. Okay, 3 minus 4 is -1, 3 plus a -4 is -1. When I write it with a plus sign and I connect the negative with the number after it and put parentheses, then I can flip the numbers around and it means the same thing. So 3 plus a -4 is the same thing as a -4 plus 3, because when I switched the numbers, I also switched the sign that went with the 4. So that is going to allow us to use the commutative property. If we start with a minus problem, we can turn it into an addition problem, and then we can use the commutative property. So that's what we're going to do up here. Instead of learning a subtraction rule, we just know that subtraction is addition of the opposite. So now we're going to take each minus sign and enclose it with the number that's behind it. And then we're going to turn everything to addition. So this will be -4. And instead of -3, it's plus a -3, plus a 2, plus a -4, plus a -3, plus a -2. And now we've written everything. We've connected the minus sign with the number after it. And now we can do this in whatever we want, because addition is the operation here, and we can use our addition rules. So let's go ahead. The -4 plus the -3 is going to be the -7, plus a 2 is a -5, plus a -4 is a -9, plus a -5 is a -14. Okay, and if we had done this just going in that direction, -4 minus 3 is the same thing as this, and we should get a -14 here when we subtract it. But we can also use the same set of numbers, and now that we've written it as addition, we can change the order in which we do it. So let's take all of our negative numbers and add them up together, and then add our positive number in. to make it a little bit easier. So negative 7, another negative 7 is negative 14. And then guess what? My negative 2 and my positive 2 will cancel. So I get a negative 14 again. And very often it's easier to do it in a different order than left to right. Now this is example 6.6, and you can see that I do this a little bit differently than your book does. Your book puts a parenthesis around every number, but I only put a parenthesis around the numbers that need a negative sign, because it's just wasted effort in my book to put a parenthesis around the positives. We don't need a positive there because it's already positive. The nice thing about this is you can already see by the parentheses which numbers are negative. So I'm going to choose to do my positive addition first. So I'm going to add my 11 plus my positive 3 to get 14. So my positive numbers sum to 14, and my negative numbers, a negative 2 plus a negative 4, that's a negative 6, plus another negative 2, is going to be plus a negative 8. And 14 plus a negative 8, opposite sign I subtract, and I take the sign of the greater, which is positive, and I get a 6. Now if I had just done it straight away, I would still have gotten a 6. Negative 2 plus positive 11 is going to be a 9, because they're opposite signs I will subtract. And then I take that 9 and add it to the negative 4, opposite signs I subtract again. So I will get, this one was 9, so 9 minus 4 is going to be positive 5. And then 5 plus 3 is going to be positive 8. And then 8 plus a negative 2, or 8 minus 2, is going to be 6. All I did was put little parentheses around each number that was negative so that I could change everything to addition. Subtraction is addition of the opposite, and now that they're all addition, I can do them in any order that I wish. This one is example 6.7, and its instruction is simply to simplify. So this one is already in a form ready to use. Now this absolute value of negative 2, isn't that just a positive 2? So let's start with a negative 4 and a positive 2, and we have a positive 3, so I don't need to change that one. And then the negative 7, I'll make a little parenthesis, change it to plus a minus 7, and plus a minus 2. So now it's easy to see all my pluses are here, and then my minuses are in parentheses. So let's do our pluses first. Get plus 5. And then you don't have to put the plus sign there. It's understood to be plus 5. And then all of our minuses added together would give me negative 11, and then a negative 2 added to the negative 11 is a negative 13, which is the same thing as a 5 plus a minus 13. They're the same. So 5 plus a minus 13 is a negative 8. And now we'll look at 6D. All right, the last section talks about this rule right here. Subtraction is addition of the opposite. So basically, we can think of it that way. We can also think of the minus sign as attaching to the number behind it. So this is our rule. And basically, 5 minus 3 is the same thing as 5 plus a negative 3. When we add opposite signs, we subtract, and then we take the sign of the greater. So we're going to use the subtraction is addition of the opposite rule throughout this book. So we're going to change our subtraction into addition. So now let's do this problem, and again, we would change our subtraction. So at least mentally, we're going to change this into plus a negative 2 plus a 7 plus a negative 6. Now, whether you actually change it to parentheses, they're telling you that you can do that step in your mind if you want to. So you can write it down or you can do it in your mind. So now we have a positive 7, but then we have 3 negatives that we can add together. So negative 5, a negative 6, that's a negative 11, plus a negative 2 is a negative 13. So we have negative 13 plus a 7, opposite signs. So we're going to end up with a negative 6 because we take the difference and then we take the sign of the greater. On this one, we can write out the negative 4 and then minus, remember the absolute value is going to end up being 2. So we have a minus in front of the absolute value sign, so it's going to be minus 2 or plus a negative 2. And then the minus 6 is plus a negative 6 plus the negative 5. They had already written that one for us. So now they're all negatives, so they're all the same sign. So I'm going to add those two together first because that makes a negative 10 and then a negative 7. So a negative 10 and a negative 7 is a negative 17. Done deal. This is your practice problem C. And again, we're going to look at this absolute value and take care of it right away. The absolute value of a negative 8 is a positive 8, but then we have a negative in the front of the positive 8, which means the opposite of 8, which is a negative 8. So plus a minus 3, plus a 5, plus a minus 11. Again, if you want to do it the way the book does it, you can put a plus a positive 5, but to me that's a little redundant. So now I've got a positive, but then I've got a negative 11, and a negative 11 is going to be a negative 22, and then a positive 5, and I subtract because they're opposite signs, and I'm going to get a negative 7, let's see, 22 take away 5, 17. And that is practice C. Okay, so this is the last practice that we have, and then you can do your homework. So here, let's just go and put it in the right form. So negative 8 plus, now we have an absolute value, and it's got a plus in front of it. So this is going to become a positive 6, so we'll just write down 6. And then we have an absolute value of a negative 5, which is a positive 5, but then we have the negative in front of it. So it's the opposite of a positive 5 or a negative 5. So we're going to put plus a negative 5 plus a negative 7. So now we have one positive number, but we have 3 negatives that we can put together. So negative 8 plus a negative 5 is a negative 13, plus a negative 7 is a negative 20. So we have a negative 20 added to a positive 6. Opposite sign subtract. I'm going to get 14, but then I take the sign of the greater valued number. And the answer is negative 14. That is the end of lesson 6 of your Algebra 1 book. And I hope you have fun doing that homework because this is kind of fun. This is Mrs. A, and may God bless your day.